Hello everyone, myself Twinkle Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. This video lecture is about Secure Hash Algorithm SHA 512. In this video lecture, we will discuss requirement of the hash function, after that simple hash function, and after that we will discuss SHA 512 algorithm, that is a message authentication algorithm. So first of all, we will see what are the requirements of the hash function. So hash function can be applied to any size message m. It should produce fixed length output small h, and it is easy to compute small h equal to h of m for any message m. So given a hash value h, it is infeasible to find out y such that h of y which is given h. That is a one-way property of the hash function. Now, for a given block x, it is computationally infeasible to find out y is not equal to x with h of y is double equal to h of x. This is known as the weak collision resistant property of the hash function. So, if both the values are not equal, then we cannot say that the hash value of both the functions are equal. So, this is known as the weak collision resistant property of the hash function. Next is, it is computationally infeasible to find the message m1 and m2 with hash value of m1 and the hash value of m2 are equal. This is a strong collision resistant property of the hash function. So this is the requirement for the hash function. Now we will see the simple hash function. The input is viewed as a sequence of n bit block, and the input is processed one block at a time in an iterative fashion to produce the n-bit hash function. So one of the simple hash function is bit by bit exclusive OR of the every block. So in simple hash function, bit by bit exclusive OR operation of the every block is performed to get the hash code. So Ci equal to Bi1 exclusive OR with Bi2 exclusive OR with Bin. Here Ci equal to ith bit of the hash code and Bij, that is the ith bit of the jth block. So Ci is getting using the ith bit block of the first block, ith bit of the second block, ith bit of the third block, so on. All the blocks are processed. That is bit by bit exclusive OR operation is performed on the number of blocks. Here m is the number of input block in the message. So this is a simple hash function. Now we will see SHA 512 or secure hash algorithm. Here 512 number is used because the output of this algorithm is 512 bit. So SHA 512 bit name is given here. So the generated hash code length is the 512 bits. Here SHA 512 bit is a message authentication algorithm because the generated hash code is appended to the message and sent to the receiver. On the receiver side, receiver will again generate the hash code using this algorithm and compare the appended value with the calculated value and authenticate the message. So SHA 512 is a message authentication algorithm which produces the 512 bit hash code. This algorithm takes as the input a message with a maximum length of less than 2 raised to 128 bits and produce the output of the 512 bit message digest, that is the hash code. The input is processed as in the 1024 bit block. So if the message length is greater than the 1024 bit block, then the message is divided into the 1024 bit block and then processed in 1024 bit block. So this is the message digest generation algorithm, that is SHA 512. So here we can see that first of all our message is of L bits. After that the padding is done. So padding is done using the 1 which is followed by the number of zeros, and after that 128 bits, that is length of the bits L is added here. So now our message is a multiple of the n into 1024 bits. After that, the message is divided into the 1024 bit blocks, that is number of blocks are divided. So M1, M2, so on, all the blocks are of the size 1024 bits block. Now we are applying the f, that is f is known as the round function here, which is consist of total 80 rounds, 80 rounds. Okay, now here each and every block are given to the input. Here first round function is given as the input of the initialization vector whose length is 512 bit, and after that additive modulo operation, this is additive modulo operation is applied and h1 is generated. Here h1 is also of 512 bits, which is given back to the next round function. So every round function takes as an input as a 512 bit block, and then round function is applied and additive modulo function is applied, and then hash code, that is 512 bit block is generated, which is given to the next round, and so on. Each and every block is processed, and the output of the last round, that is hn, is our final hash code or the message digest. So in this way all the blocks are processed using the round function and additive modulo operation, and the hash code is generated. Here round function, as I have mentioned that round function has 80 round. So round function is very important function which will use the 64-bit 8 buffers, which is known as the A, B, C, D, E, F, G, H. So total 8 buffers are used, each of the size of 64-bit. Now we will see each of the process one by one. So first is append the padding bits. So on our original message we are appending the padding bits. The message is padded so that its length is congruent to 896 modulo 1024 bits. So padding is always added even if the message is already of the desired length. Thus the number of padding bits is in the range of 1 to 1024 bits. The padding consists of the single 1 bit followed by the necessary number of the 0 bits. Next step is the append the length. A block of 128 bit is appended to the message. This block is treated as an unsigned 128 bit integer and contains the length of the original message. The message the message is now an integer and the multiple of the 1024 bit after the step 2. The next step is, as we know that the round function uses the different size of the buffer. So now we have to initialize the buffer. So the outcome of the first two steps produce a message that is an integer multiple of the 1024 bit in the length. The expanded message is the multiple of the 1024 bit. After that, a 512 bit buffer is used to hold the intermediate and the final result of the hash code, which are the 64 bit register, that is A, B, C, D, E, F, G, H. So now we are going to initialize the buffer. After that, we are going to process the message in 1024 bit block. So this is the heart of our algorithm, which uses the modulo. This module uses the total 80 rounds, and this module is labeled as a F. So now we will see how each of the buffer gets updated in the SHA 512 algorithm. So first of all here we can see that the every round function takes the total 8 input as a 8 buffers, constant k0 to k79. This constant is generated using the random number generator, and also take the w0 to w79, that is the word, keyword or the word, using the message schedule. This message scheduler will generate the words from the original message, and w0 to w79 words are generated. And another input to the round function is the hash. Another input to the round function is the hash value of the previous round. So the first round will take the initialization vector, and the second round will take the output of the first round. In this way all the rounds are in this way all the buffers in the all the rounds buffers, the value of the all the buffers are gets updated, and after the round 79, that is round 80, because here we are starting from 0. So after the round 80, additive modulo operations is perform. So the output of the 18 round is added to the modulo 264 to the input to the first round, that is HI minus 1, to produce the HI. So here consider that the plus is not a exclusive OR operation, it is a additive modulo operation. So in this way all of the round is performed in the round function f. Next, we will see each round takes as an input the 512-bit buffer value ABCDEF and updates the content of the buffer. At the input, the first round, the buffer has the value of the intermediate hash value, that is HI minus 1, and also it will take the 64-bit value WT, which is derived from the 1024-bit block being processed, and the output of the 18, that is 18 round, is added to the input to the first round to produce the HR. So in this way all the round or the SHA algorithm is performed. Next is the output. So after all the 1024 bit blocks have been processed of our original message, the output from the last block is the 512 bit message digest, that is our hash code. So now we will see each round how to each of the buffer gets updated in the each round. So this figure shows how each of the buffers gets updated in the round function. So we will see using the formula. First of all, we will see that buffer A equal to T1 plus T2. Now what is T1 and T2? T1 equal to H plus conditional operator applied between EFG plus summation of 1 to 512 on E plus WT plus KT, and T2 equal to summation is applied on the A from 0 to 512 plus majority function is applied on the ABC. Now we will see what is this conditional function, what is majority function, and what is summation function. So here see that majority function is the function which is true only if the majority of the arguments are the true. So majority of ABC equal to A and B exclusive OR with A and C, which is exclusive OR with B and C. Now we will see what is summation of A. Summation of A equal to circular right shift of the 64-bit argument, that is the circular right shift of the A bit argument by the 28 bits, exclusive OR with circular right shift of the A with the 32 bits, which is exclusive OR with the circular right shift of the A with 39 bits. In the same way, summation of E, which is equal to circular right shift rotation of the E with the 14 bits, circular right shift of the E with the 18 bits, and the circular right shift of the E with the 41 bits. Here plus is the additive modulo to 264 operation. It is not an exclusive OR operation, and KT is the 64-bit additive constant. And here also the conditional function, that is CH of EFG, which is the conditional function, that is if E then F, if E is true then F, otherwise G. So which is equal to E and F exclusive OR with not E and G. So this is the conditional operator. If E is true then F, otherwise G. So this is the conditional operator, majority function, and summation function. So we will see in the figure. So A equal to T1 plus T2. So first of all T1 equal to H, that is H, additive modulo operation, plus summation of E, okay, plus WT plus KT. So we are getting the T1 here. Now we are applying the T2. A equal to T1 plus T2. So now T2 equal to summation of A. So summation of A plus majority function applied on the ABC. So the output is given to the additive modulo operation, and these two are added. So T1 plus T2 we are getting A. So in this way all the buffers gets updated in the each of the round function during the total 79 rounds of the each of the blocks. So in this way message digest is generated in the SHA 512 algorithm, which is used to authenticate our message. That is, it is a message authentication algorithm. Thank you.